You know, hidden away in a panel somewhere in your house, there's a small device that stands guard 24/7. It's the silent protector you probably never ever think about, until of course, the lights go out. So let's dive into this unsung hero of electrical safety, the miniature circuit breaker.
I mean, really think about it for a second. We've got all this powerful stuff plugged in, complex wiring running all through our walls, so what's stopping a simple little fault from turning into a total disaster? Well, the answer is this humble little switch.
Now, some of you might be thinking about old school fuses. And yeah, you're right, fuses were the original solution. They're basically designed to be a one-time use weak link. When the current gets too high, a little wire inside literally melts and breaks the circuit. Simple. But the catch? You have to physically replace it every single time it blows. That's where the miniature circuit breaker, or MCB, completely changed the game. It's the modern, reusable, and frankly, much safer way to do things.
Okay, so let's get properly introduced to our silent guardian here. What exactly is this little device that's become such a critical part of modern electrical safety?
The key phrase to focus on is right there in the definition. It's an automatic electromechanical switch. See, it's not just a switch you flip on and off. It's a smart device that is actively sensing for danger, in this case, too much current, and it automatically shuts everything down before any real damage can happen.
And here's what one looks like up close. You've got the main lever that you use to reset it, that little indicator window that tells you if it's on or off, and the terminals where the wires hook up. It's a really simple exterior for what is actually a very sophisticated piece of engineering on the inside. Okay, so here's where it gets really clever. How does this thing actually know when to trip? Well, an MCB isn't just looking for one kind of problem. It's actually built to handle two very different kinds of electrical threats, and it uses two totally separate defense mechanisms to do it. It's almost like it has two brains.
So the two threats are overload and short circuit. An overload is kind of like a slow burn. Imagine you plug a toaster, a microwave, and an electric kettle all into the same outlet. The current slowly starts to climb past a safe level. A short circuit, though? Whoa, that's a completely different beast. It's a sudden, violent, near instantaneous surge of current, usually because of something like damaged wiring. And to fight these two threats, it's got two different weapons. For that slow overload, it uses a thermal defense, a really neat little strip made of two different metals stuck together that physically bends when it gets hot. But for that lightning-fast short circuit, it uses a magnetic defense, a coil of wire that turns into a powerful electromagnet the instant a massive current zaps through it. So how do these two systems actually trip the switch? Let's take a look inside.
All right, let's pull back the plastic casing and see these two mechanisms in action. Seeing how it all works really gives you an appreciation for how elegant the design is.
And there you have it, all the parts working together inside that little box. You can see the bimetallic strip for that slow thermal protection, the magnetic coil for the instant protection, and then this really intricate latch system that both of them are designed to trigger.
Okay, so here's the overload protection play-by-play. The electricity is always flowing through that bimetallic strip, but when you start running too many appliances, that strip gets hotter and hotter. And because it's made of two different metals that expand at different rates, it starts to bend. After maybe a few seconds or even a couple minutes of this sustained overload, it finally bends far enough to pop a latch and click, the power's cut. It's patient. It's designed to ignore small, harmless little power fluctuations. The short circuit protection, on the other hand, is all about speed. When a short happens, a huge, dangerous rush of current flows through that coil. This instantly creates a powerful magnetic field that shoots a tiny plunger forward, and that plunger physically smacks the same latch mechanism. This isn't a slow bend. It's a forceful, immediate strike that snaps the circuit open in milliseconds, way before that massive current has a chance to melt wires or start a fire.
Now, this quote highlights a safety feature that is absolutely critical. It's called trip-free. What does that actually mean? It means the internal mechanism works on its own. So even if you were to physically hold the switch in the on position while there's a fault, it will still trip inside and cut the power. You cannot override its safety function, which is exactly what you want.
So you can't just go and grab any old MCB off the shelf and expect it to work. Just like any specialized tool, they come in different types, and each one is calibrated for a very specific kind of job.
If you look closely at an MCB, you'll see a bunch of codes and numbers. And it's not just random text, it's basically the device's resume. The most important things for you to know are the letter, like B or C, which tells you its type, and the number right next to it, which is how many amps it's rated for. So a C32 is a Type C breaker rated for 32 amps of current.
So what's the big difference between, say, a Type B and a Type C? Well, it all comes down to their sensitivity. A Type B breaker, which is really common in homes, will trip when the current hits about 3 to 5 times what it's rated for. It's sensitive, and that's great for things like lighting circuits. A Type C, though, is tougher. It waits for the current to be 5 to 10 times the rated load before it trips. Why? Well, think about a big motor. When it starts up, it draws a huge but very brief surge of power. A sensitive Type B would trip every single time. The Type C is designed to ignore that initial kick and not cause a bunch of annoying false alarms.
So as we wrap up, it's pretty obvious the MCB is way more than just a switch. It's a really sophisticated piece of protective tech that honestly enables our entire modern way of life.
And today's MCBs are just packed with cool features. For instance, they have something called an arc chute. It's basically a little chamber with metal plates inside designed to safely extinguish the dangerous electrical spark, or arc, that forms when you break a high-power circuit. They're designed with little grooves for better air circulation to stay cool. And they have a high energy limiting class, which is just a technical way of saying they trip so incredibly fast that they stop the destructive energy before it has time to damage the wiring in your walls.
So the bottom line is this. Without these reliable little devices, our homes, our offices, our factories, they would all be far more dangerous places. They are the tiny enablers of our electrified world. They prevent fires, they protect expensive equipment, and they make sure the lights stay on. And that really brings us to the end. The MCB is just a perfect example of brilliant engineering made simple, reliable, and invisible, all to keep us safe. It kind of makes you wonder, right? What other hidden guardians are out there, quietly doing their job for us every single day? Thanks for joining me.
Please like, share, and subscribe for more learning and appreciation. I am Batman.